All right, it's time for a geometry video. That means happy dance. All right, happy dance out of the way, listening to a song called Get Over It. It's time to roll. Today we're gonna learn how to find the area of a regular polygon using trigonometry, the best way to do it. You ready? You got your trigonometry with you? All right, this is gonna be time to get it. It's gonna be time, here we go. First thing we're gonna do is I'm gonna put a regular polygon. Just means polygon where all sides are the same length. You ready? Let's go get it. Okay, so we have a pentagon here. It's a regular pentagon. Let's say it's stated as a regular pentagon, and the side length is 10. What's the area gonna be? All right, so we've got a few steps to figure out. So first thing I'm gonna do is I'm gonna maybe, I'll just tell them to you. Step number one, we're gonna model it as a right triangle, okay? So what I want you to do is you go up here, find the center, and just draw your lines to each little vertex there. Nice. And what it does is it creates 5 angles that are exactly the same. If it was a hexagon, it would create 6 angles that are the same. Now the next question is, what are these angles? Well, you got 5 angles. They're all the same. They have to add to 360. I'm smelling some division here, right? Let's do it. So what we're gonna do is we're gonna say, okay, 360 divided into 5 equal angles at 72 degrees. So that's the first step, because we're going to use trigonometry. And when someone's saying use trigonometry, it's right triangle trigonometry. So we need those right triangles. So what we got is these are all 72. So then what we're going to do is we're going to draw the apothem, which is this line from the center that's perpendicular to the side, okay, which bisects the 72-degree angle. Guys, in geometry fun. Love using the word. It bisects the angle. Beautiful concept. And so what I'm going to do is I'm just going to actually draw this orange triangle. Just kind of explode it out, if you will. It looks like it's here and here's drawn a little bit bigger so you can see it. If this whole length is 10 and this length would just be 5, right? Because this is just the orange part of the triangle. All right. We know this angle is 36 because this half is 72. And now we want to find the area. Because how we're going to approach this is what we're going to do is we're going to find the area of one right triangle. And we realize that this pentagon is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 of these little right triangles. So whatever the area of this triangle is, the area of the pentagon is going to be that times 10. So let me write that. All right. So the area of the pentagon is going to be 10 times the area of this right triangle. So the area of a right triangle is always base times height when the right triangle is oriented to where the right angle is laying nice there flat on the floor. So what I'm going to say is I'm going to go base times height. So we really need this value here, x, okay? That's what we're looking for. So we have an angle. If we have an angle and a side length, we can use trigonometry to find any one of these other sides. So what I'm going to do is use my trigonometry. So first, find, where's my other colors? Find the opposite side. Told myself I had enough colors here. For whatever reason, I feel like I need more. I don't know, maybe it's a personal problem. Okay. Opposite side of the angle 36. The hypotenuse, the adjacent side. So what we have here, opposite adjacent, that's a tangent. So let's solve for x. The tangent of 36 is equal to the ratio of the opposite over the adjacent, so 5 over x. Beautiful. Let's figure out what the tangent to 36 is. So we got 0.7265 is equal to 5 over x. Put that over 1. And give us an opportunity to cross multiply to solve for x. So we're going to multiply the number on the top of one ratio to the bottom of the other ratio. And we got 0.7265 times x is equal to 5. Now we divide. Let's divide. 5 divided by 0.7265, 6.9 rounded. Okay, so x is approximately 6.9. Beautiful. So now I know this value. It's about 6.9. Gorgeous. The other thing we could do is just remember, you just got to remember that the tangent always multiplies the adjacent to get to the opposite. So if you have to go the other way, you just divide. So we could have just divided by 0.7265. If you just use scale factor, right? So if I divide, I got to, of course, well, I'll do it as a multiplication. So you multiply when you go that way. So if you're going to go the other way, you would divide. All right? So 5 divided by that number is that number. All right. Well, we're almost there. We're almost there. I feel another happy dance on the way. So we got 10 times the area of the triangle, which is going to be 1/2 the base times the height. So we're going to go 1/2, 5 times 6.9. Yes, sir. I don't know. Is this song even still playing? Oh, come on. Keep playing for me. Keep playing for me. We just got there. Oh, yeah. I feel coming back on. Happy dance. We got a solution. Good job, everybody. Let me describe it one more time, Lo. Let me describe it one more time. Oh, man. We doing all right. So all we do is we draw the right triangle, figure out this central angle, cut it in half, use trigonometry to get our dimensions, and then we rock and roll right to the end. All right? I want you to try one now. So what I'm going to do is erase this, and I'm going to give you a different polygon. All right? Let's go. All right, so now we have 1, 2, 3, 4, 5, 6, 7, 8-sided object, which is an octagon. I'm telling you it's regular. Of course, I didn't draw it perfectly, but let's just assume all these sides are exactly the same. This time, I gave you the apothem. Right? Apothem. I didn't give you the side length of the polygon. Either way, that's why I'm teaching this with trigonometry. Because now, let's see if you can do it this way, all right? So hit pause and calculate the area of this. Pause. Unpause. All right, well, step 1, I'm going to break this shape into right triangles. And then I'm going to add all those areas of those right triangles because they're all going to be the same. So let's get that first. Let's go. Okay, so all these angles, there's 8 of them. I'm going to erase that for a moment. All 8 have to add to 360. So we go 360 divided into 8 equal parts gives us, should have thought of it, 45 degrees. So they're all 45 degrees there. So let's get that next. Okay, so these are all 45s. All right, so if this whole angle is 45, remember we need to bisect that 45-degree angle. That apothem bisects it. So 45 divided by 2 is 22.5. There we go. We got our angle. We got our side. Oh, we looking at a right angle. So all we need is now just this value here. X. That's it. So let me kind of draw this right triangle bigger for you. All right, so the nice thing about this is you have to be given one of the sides, but at that point you're good. Like you could have been given the hypotenuse as well, which is the radius of the shape if I enclosed it in a circle. But either way, here we go. We've got an angle, we've got a side length, we got a right triangle. Someone say trigonometry for me. Well, someone said it. I'm gonna think someone out there said it. We'll see. All right, so switch into trigonometry mode. Find the opposite, the adjacent, and the hypotenuse. Let's go. All right, opposite side. I like to draw the angle there, or draw the arrow. That's the opposite side of 22 degrees. We got the hypotenuse. Therefore, by a process of elimination, we got the adjacent side. So you got to figure out sine, cosine, tangent. What, you forgot those ratios? Are you serious? Are you serious? Let me write them for you. Okay, so sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And really, the rub here, or the hint, is if you're dealing with the right angle, that's tangent. You're dealing with the right angle, that's tangent. So let's write our equation up and see what we got going. So I'm going to write it here. So we got the tangent of a 22.5 degree angle is equal to the ratio of the opposite side to the adjacent side. Now, the quick, if you like to use kind of just like scale factor techniques, is you could just know that tangent always does that. It always multiplies the adjacent to get to the opposite. So you can just go to your calculator and do tangent 22.5, hit enter, you get 0.414. So then all you do is you say 12 times that number is that number. Let's do it. 12 times 0.414 is, grab the purple marker, this value here is going to be 4.97, which you could get by solving that and cross multiplying, or just multiply both sides by 12. Either way, we get that value, that's 4.97. I didn't put any units in this problem, but it doesn't matter the units. If it's centimeters, centimeters. If it's inches, it's inches. All right. So now if we've got that, now we got to find the area of this triangle. And then we're going to multiply that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? And I knew it was 16. I don't know if I counted right, but each triangle has 2 of these, right? So there's 8 of these bigger triangles. Therefore, there's going to be 16. So let me write that. If you've been watching a few videos, you're going to learn. I know when he started doing these during lunch because that bell comes in. Don't worry, I got a little bit more time. So I got to find the area of this triangle. So I got 16 times 1/2 the base times the height. So 1/2 4.97 times 12. So we have 16 times approximately 300. So I guess it's 301 if I'm rounding correctly. Approximately. Remember our units, our area is units squared. So I didn't have units in this problem, but I'll just say units squared. All right. Hey, you can do a happy dance. It's all right. It's okay. You know, it's fine. So in general, what you're going to do is you first break it up into these equal triangles, find that central angle, create your right triangle. It's going to take trigonometry to find these 2 sides, or one of the 2 sides. Find the area of that triangle and multiply it by how many there are. So really the only thing that's going to change in the polygon is that angle. That's it. And that number. So if this were like a size 10, that number is going to get smaller. It's going to be whatever 360 divided by 10 divided by 2 is. And then that number would become 20, right? Could be bigger. That's it. All right, now you can do any polygon in existence. Remember to stay hip and be kind to each other. And I'll see you around. Happy dance.